Okay, so in this video, I'm going to talk about shifting and stretching functions just with an example. So I'm just going to give an example in this graphing calculator and do some shifting and stretching of the function so that you can see what happens, and I'll kind of explain why certain things are happening. So the example that we're going to look at is f of x, which is, it's going to be a cubic function. So x cubed minus 4x squared minus x plus 4. Okay, so we have this nice function here that I've called f, and it's just some cubic function that's defined this way, defined by this formula. Okay, so now I want to look at shifting and stretching. So the easiest thing to understand is a vertical shift. Okay, so what that means is I'm going to define a new function, g of x, and I'm going to define it by taking f of x and just moving it, by just shifting it vertically. And the way that I do that is I take f of x and I add something to it. So let's say I add 2 to it. So you can see that the red f was the red function and g is this blue function. Let me shift it by 3 so that it's a little more obvious. So g is this blue function, and how have I defined g is I've defined it by taking whatever f was and adding 3 to it. And so if I graph this function, if I take my function f, the red curve, and I just add 3 to it, this is going to shift it up by 3, right? And you can see this with the blue graph. It's just 3 units higher. In every x position, it's 3 units higher than the red graph is in the same x position. So for example, the red graph at x equals 0, the y value is 4. The blue graph at x equals 0, the y value is 7, so 4 plus 3. And it makes sense with the formula. What am I doing? I'm just taking the y value, the f value here, and adding 3 to it. Okay, so if I take a function f and add a value to it, that vertically shifts it by that same value. So if I take f of x plus 3, it would shift it vertically by 3. If I took f of x minus 3, that would shift it down by 3 because I'm subtracting 3. Okay, now let's talk about horizontal shifts. If I define a function h of x, which is f of x, and now I'm going to shift it horizontally. And how this manifests is if I add inside the input. So if I do this function composition where I add inside the input here, so I define h of x is f of x plus 6 now, then this, it looks like it shifted it to the left here. So let me get rid of this g function so that it's more clear. So I had my f of x, the red function, and now I have this green function, and changing the input from x to x plus 6, what did that do? It looks like it shifted it left, and we can check, it looks like it shifted it left by 6 units. So let's check a point where it crosses the x-axis. So the leftmost point where the function crosses the x-axis is -1 for the red graph, and it looks like it's -7 for the green graph. So it looks like it shifted it to the left by 6. Some students get confused. This is a plus sign, but it shifted left instead of right. And you can, so it's sort of backwards from what you might expect. And you can think about why that is. So for example, if I want to look at where on the green graph is the corresponding point to this -1, 0. So in the function f, when I plugged in -1, the output was 0, right? And so that's corresponding to this point on the red graph. And if I want to find the corresponding point on the green graph, well, I would say h of what is going to correspond to that? Well, what input x do I need to make it so that I see f of -1, right? So that's on the red graph, the formula we're looking at here to see this point is f of -1 equals 0. So what value x do I need to put in to see f of -1? Well, I'm taking f of x plus 6 here, so I need to put in -7 here, right, to get f of -7 plus 6, which is f of -1, which is 0. So that's going to correspond to this point. So that's why it's shifting to the left rather than the right. And you can see if I change this to a minus instead of a plus, it's going to shift to the right by 6. Or you can think of it as shifting to the left by -6. Okay, so these are the ways to shift a function. If I add kind of outside the function, it's going to shift it vertically because it's adding to the y output. And if I add kind of inside the definition of the function, this is going to shift it horizontally because it's changing what the input to the function is, and it's just shifting what is that input. Okay, so now let me talk about stretches. So I'm going to define another function. Let me call it a of x. And this is going to be defined by, let's say, 2 times f of x. 2 times f of x. And what's happened here, it looks like the function has been stretched vertically. So you see like the zeros are still in the same place on the function, but the, let's say this curve that's doing this is just bigger, right? It's been amplified by a factor of 2. And if I look at how I define this thing, it sort of makes sense, right? Like I'm taking the red graph and I'm just multiplying the y value by 2, right? The f of x is telling me what is the y value, and I'm multiplying it by 2. So everything gets sort of twice as big as it was before. So here, the red graph goes through the point 0, 4, and now it's going to go, the purple graph is going to go through the point 0, 8. If instead of 2, I made it 0.2, so I'm multiplying by 1/5, everything is going to get shrunk by a factor of 5. So here, where it was 0, 4, and now it's 0, 4/5 is 8/10. Okay. So it's shrunk by a factor of 2. So multiplying kind of in front of the function like this is going to stretch vertically. Okay, and now for a horizontal stretch, I'll define this, finally, this fourth function, b of x, which I'll define by f of, let's say, x divided by 3. Okay, let me get rid of these other functions to make this slightly more clear. So I started with my red function f of x, and now I'm taking this, I guess that's black, this black function b of x, which is f of x over 3, and it looks like it's sort of stretching it out horizontally. And you can think about, why is this the case? So let's consider this 0.1, 0 on the red graph. Where is the corresponding point going to be on the black graph? Well, it's going to be whatever x value I need to put in here to get f of 1, right? So that's f of the 0.1, 0 on the red graph is because f of 1 is equal to 0. And so what x value do I need to put in to get f of 1? Well, I need to put in b of 3 is f of 3 over 3, which is f of 1. And so this 0.1, 0 on the red graph is going to correspond to the point x equals 3 on the black graph. So it's 3, 0 here. And so this, this dividing by 3 within what you put into the function is going to stretch by a factor of 3. And if I multiply by a factor of 3, the opposite's going to happen. So if it's going to sort of compress by a factor of 3, or you can think of it as stretching it out by a factor of 1/3. Okay, so you should play around with shifting and stretching. In particular, you should play around with doing more than one of these at the same time. So I can take a function, I can shift it horizontally and vertically, I can stretch it horizontally and vertically, and I can do these in combination with each other. So you should try to do this with some examples and just see what happens and get a feel for it.